Hi, class. This is our day two homework two lesson. And so we are now adding and subtracting rationals. Again, I want you to kind of think back to normal fractions where we don't have these binomials or trinomials being added or subtracted. If I have just normal fractions, so let's say I have like 3/5 plus 4/5. Okay. In order to add or subtract fractions, the denominators or the bases, we usually just say the denominators, must be the same. If the denominators are not the same, then you have to actually change them so that they match. Then you can add or subtract. So in this first part of the unit, we have them so that they're already matching, just so that we can get used to it and see how adding and subtracting work. In the next part, the bases don't match, and so we actually have to change the bases so that they do match, okay? And so when they do match, if you recall, we just take those matching ones and carry it over. And then up top is where we can add. So we get 3 plus 4. And so our final answer would be 7/5. Okay? So from that example, let's go ahead and try this first example. This is number 3 on our notes for day 2. Okay, so this is going to help you with homework number 2. So the good news is the bases already match. And so we're just going to carry that base over to the new denominator because we can just carry it over. So it still will be y squared minus 9 on the bottom. Now when we're up top, we can add. Now when we're adding things with variables, you need to be careful. You can only add like terms. So in this case, the only y squared on both tops is that 1y squared. So we're going to have y squared. Okay. But we do have an 8y and a 2y, and we're adding those. Okay, so we have 8y plus 2y. Those are like terms, and so we can combine those. And so we'll get 10y. And then that 21 is the only constant, and so we'll bring it over and we'll have 21. Okay, now this turns into what we had been doing on day 1 in homework 1, where we just have to simplify now. And so you're going to want to factor as much as you can. And so on the numerator, we can try AC method here. So we're going to have A times C, which is 21. We want to find two numbers that are multiplied together that give us 21. But when I add them, they give me 10. And so if I do 7 times 3, well, 7 times 3 is 21. But 7 plus 3 gives me the 10. And so we can change this numerator to y plus 7 and y plus 3. Okay, I'm going to erase this just so we don't get it confused, but that's where it came from. In the denominator, we can actually simplify these also. These are difference of squares. And so going back a few chapters, when we have something squared minus one of the perfect squares, it is the same number with an opposite sign being multiplied. Because what that means is that middle number, those middle terms got canceled. And so we're just left with the y squared minus 9. Okay? If we're asked to give the restrictions, this is the point where you would give the restrictions. Okay, we have y minus 3 and y plus 3. And so if I set both of those equal to 0, you get the opposite. And so my restrictions in this case are y cannot be negative 3, nor can it be 3. Okay? Now we can cross out matches. So we have a y plus 3 here and a y plus 3 here. And so our final answer is y plus 7. Y plus 7 over y minus 3. And that would be your final answer. We cannot simplify anymore. Again, that looks a little funky. So y plus 7 over y minus 3. Okay, with restrictions of -3 and 3. So that is adding, and there's the same rule with subtracting when you have common bases. The next video is when we don't have common bases.